Welcome back, everyone. Today we're diving into something pretty essential for accurate diagnoses, especially in fields like, dentistry and orthodontics. We're going to be talking about the challenge of noise in radiographic images. It's something Dr. Baxmann talked about, and it really got us thinking.
Yeah, it's fascinating, isn't it? I mean, we tend to think of x-rays as these crystal clear windows into the body, but the reality is there's often a lot of interference,
Yeah,
things that can obscure the details.
exactly. And Dr. Baxman, being the expert he is in both orthodontics and AI, he really emphasized how even these subtle distortions, they can have a huge impact on treatment planning.
Think of it like reading a text message, but it's like a whole of typos and random characters.
Well,
It's just hard to understand, right? That's kind of what noise does to an x-ray image. It introduces these random variations that make it difficult to interpret.
makes sense. And especially in orthodontics, where precision is so important, relying on a noisy image. Well, that could lead to all sorts of problems: misdiagnosis, incorrect treatment, even a compromised outcome for the patient.
Dr. Baxman made a point that really stuck with me. He said, noise reduction isn't just about making the images look pretty, it's about getting the most meaningful information possible. That's the goal.
So it's about enhancing those specific details that are really crucial for diagnosis and planning the treatment.
Precisely. And that's where AI is really changing the game. Traditional denoising methods, they always involve this trade-off, reduce the noise, but then you sacrifice sharpness. It was frustrating.
Like trying to remove static from an old photograph by blurring it, right? You might reduce the graininess, but you lose the details.
Exactly. And Dr. Baxman, he pointed out that this trade-off has been a major, major obstacle, especially in orthodontics, where you need to identify those landmarks so precisely.
Okay, so then how does AI solve this? What's the secret sauce here?
Well, the magic, if you will, lies in something called convolutional neural networks, or CNNs. They're algorithms, you see, designed for image processing. And what's really cool is their ability to learn from huge amounts of data.
So you're basically feeding the AI tons of images, some noisy, some not, and it starts to see patterns.
Exactly. Through a process called regularization, the AI figures out what's actual anatomical detail and what's just random noise.
It's like almost like training a radiologist, right?
Yeah.
Someone who's seen millions of x-rays and can instantly tell what matters.
That's a great analogy. And that's how AI can denoise images while keeping those important details intact.
That's incredible. But I imagine there are different ways AI can approach this denoising task.
Yeah.
It's not just one method, right?
You're absolutely right. There are different AI architectures for this. One common approach is, it's called the encoder-decoder model. Imagine compressing a digital file to make it smaller, right? And then decompressing it to get the original back. That's basically what the encoder-decoder does, but with an image.
So it's like analyzing the image, figuring out the key features, and then rebuilding a cleaner version.
Yeah, that's the gist of it. And it's been pretty successful in reducing noise while maintaining image quality.
But Dr. Baxman seemed particularly excited about something else, something called generative adversarial networks, or GANs.
He was. And for good reason. GANs are a step up, you see. They don't just filter or enhance existing images, they generate completely new ones from scratch. It's like having an AI artist create a noise-free interpretation of the original X-ray.
Wow. And how do they make sure these AI-generated images are accurate? How do they know they're getting the anatomy right?
Well, GANs are interesting. They work by basically pitting two neural networks against each other. One creates images, the other tries to figure out if they're real or fake. It's a competition.
So they're constantly pushing each other to improve.
Exactly. And through this process, the generator gets incredibly good at creating realistic, noise-free images. It's pretty amazing, actually.
Fascinating stuff. But we've been talking about these AI techniques in a kind of abstract way. Are there real-world examples of this technology in action?
Absolutely. And this is where Dr. Baxman's enthusiasm really shines. He's a big advocate for Carestream. They're a company leading the way in AI-powered denoising for dental imaging.
Nadia, I've heard of Carestream. They developed something called smart noise cancellation, right? SNC.
That's right, SNC. And it's been a real game changer for a lot of orthodontists.
I'm really curious to hear more about how SNC works, what makes it so effective.
One of the most interesting things about Carestream's SNC is that it uses a deep convolutional neural network, but the real key is the data set, right? The data they used to train it, it was huge. and diverse.
Yeah, you mentioned that before. Dr. Baxmann was really impressed by that. What made it so special?
It's not just the number of images, but the types, They had patient images, cadaver images, even phantom images.
Phantoms, what are those?
Basically, they're like artificial models, They mimic human anatomy. They're often used in like testing and calibration for imaging.
So by using phantom images, they're making sure the AI can handle like a wider range of situations.
Exactly. Dr. Baxmann really emphasized that, that comprehensive training. That's what makes Carestream stand out. And that's why it works so well.
Makes sense, yeah. It's like you're giving the AI this like really well-rounded education, exposing it to all these possibilities so it can like really perform in real-world settings.
That's it. And the results, they're impressive. Carestream's SNC, it reduces noise, enhances contrast, improves resolution, all without sacrificing sharpness. It's pretty remarkable.
Yeah, and Dr. Baxman talked about how important that is for orthodontists, right?
Mhm.
Especially when they're trying to identify those like really subtle landmarks, the ones that are so crucial for making a diagnosis and planning treatment.
He did, and he even mentioned that Carestream's SNC got FDA approval, Yeah, so that adds a whole other level of like credibility assurance for the clinicians using it.
For sure. FDA approval.
Yeah.
That means this technology has met some like pretty rigorous standards, right? For safety and effectiveness. So orthodontists can feel good about using it in their practice.
Absolutely. It really shows how far AI has come, and its potential to like fundamentally change the way we approach diagnostics. It's huge.
It is. And it's important to remember, AI isn't supposed to replace doctors or dentists. It's more about like enhancing what they can do.
Yeah, it's a
tool, right? To help them see things more clearly, make better decisions.
Right. Dr. Baxmann used this analogy. I thought it was good. He said like AI, like a really skilled assistant, the one who handles all the like tedious, repetitive tasks. So the clinician can focus on the patient, on the more complex stuff.
Oh, that's a perfect analogy. It's like having this like superpowered sidekick, right? Who can analyze images with like incredible precision. So you, the doctor, can spend more time with the patient.
Exactly. And, we've been talking a lot about like the technical stuff with AI denoising, but Dr. Baxmann, he also brought up some ethical considerations, some important things to think about.
Yeah, he did emphasize that. Responsible development and use of AI in healthcare.
No.
Some of the things he was concerned about.
Well, one of the big ones is bias. Making sure AI systems are trained on diverse data sets.
Mhm.
If the data is skewed or incomplete, the AI might like perpetuate those biases. And that could lead to real problems like disparities in care.
Yeah, that makes sense. It's a big responsibility, right, for developers and users of this tech. We have to make sure it's fair, as equitable.
Absolutely. And another thing is transparency. Patients need to know how AI is being used in their care. And they should have the option to say no, if they're not comfortable with it. Building trust is so important. And that comes from open communication, respect for the patient's choices.
Right, totally. It's about giving patients information, making sure they're comfortable, confident in the care they're getting. It's not about replacing human judgment with like algorithms. It's about using AI as a way to improve human capabilities, to get better outcomes for patients.
Absolutely. And, that brings up another interesting aspect of AI. Its potential for personalization and prediction.
You mean like tailoring treatments to each patient and maybe even like anticipating what the outcome will be?
Exactly. Imagine being able to like simulate different treatments, right? And see how a patient might respond all before doing anything. It could be revolutionary, how we plan treatments. We could get even better results.
And Dr. Baxman even talks about like maybe using AI to develop new imaging techniques, right? Ones that are even more precise, less invasive.
It's incredible to think about. The possibilities are endless, really. It's a really exciting time to be in this field, seeing how AI is pushing the limits of what's possible in healthcare.
Yeah, feels like we're just at the beginning, of what AI can do. But before we get too ahead of ourselves, it's probably good to like take a step back and think about what we've talked about so far, the journey we've been on.
Yeah, for sure. We've covered a lot of ground today. We started with like the whole problem of noise, then the promise of AI, real-world applications, and now we're thinking about the future. What stands out to you from all this? What really stuck with me was that story Dr. Baxmann told about his colleague, right? The one who was having trouble diagnosing a root fracture. Remember, the x-rays were so noisy, like you could barely see anything.
Yeah, he said that running the images through Carestream's SNC, it was like somebody suddenly turned the lights on. The fracture was just like crystal clear.
And think about it, right? Catching it early like that, it could have made a huge difference for the patient.
Hmm.
Their treatment, their long-term outcome, it could have changed everything.
It really shows how AI can actually make a difference, right, in people's lives. It's not just some theoretical thing.
Totally. It reminds me why this field is so exciting. It's not just about the technology, the algorithms. It's about using it to help people, to improve care, maybe even save lives.
For sure. But even with all these amazing advancements, we have to remember there are challenges, right? Responsibilities that come with using AI in healthcare. We need to be working towards a future where AI-powered diagnostics are available everywhere, right? Not just in fancy hospitals, but in underserved communities too, places with limited resources.
And it's not just about the technology, right? It's about education, training. Clinicians need to know how to use AI the right way, effectively, ethically.
Yeah, it's a team effort, right?
Right.
Researchers, developers, policymakers, clinicians, all working together to build a healthcare system where AI is integrated the right way.
Exactly. And at the end of the day, it's about empowering people, giving clinicians the tools to make better decisions, giving patients the information they need to feel good about their care, to be involved in the process.
Couldn't have said it better myself. It's definitely an exciting time. Things are changing so fast. And, as we wrap up this deep dive, I'm feeling two things: optimistic about the potential of AI
Hmm.
and a sense of responsibility, to make sure these advances help everyone.
Well said. To all our listeners out there, stay curious, keep learning, be part of this conversation. The future of healthcare is happening now. We all have a role to play in shaping it.